In this problem, we'll begin to look at some exercises from Chapter 4 and Section 2. We consider the function f of x is equal to 3x plus 2. So let's graph that real quick. With these types of problems, you really want to make a quick and dirty graph of the situation. So we start off with a little graph here. It goes from, on the y-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and goes from 1 to 3 on the x-axis. Alright, so if we wanted to graph this, we would start at x equals 2, the y-intercept, then go up 3 over 1, up 3 over 1, and finally up 3 over 1. And we would do our best to make a straight line through that. And that would be the graph of that. Now we're looking for the area under the curve from 0 to 3 here. And we could actually calculate that area using the trapezoidal approximation. And that would be the area of a trapezoid is the height over 2 times the sum of the bases. In this case, the height is the perpendicular distance between the pair of parallel bases. And so that's going to run from 0 to 3. So we have 3 over 2 times the first base is 2 and the second base is 11, and so we would have 13 times 3, which would be 39 halves, and we're going to see later we'll like to look at this in fourths, and that would be 78 fourths. Alright, so that's the actual area, and you might ask, well, if we can find the actual area that easily, why do we want to do this? Well, we're trying to illustrate a point here of how areas between the curve and the x-axis are originally calculated, and this is going to lead us into the concept of the integral. So what we want to do here is use 6 rectangles, and we want to use right endpoints. So we need to break the x-axis down from 0 to 3 into a more fine detail there. So we're going to go from 1/2 to 1, 3/2 to 2, 5/2 to 3. We want to use the right endpoints. Well, what does that mean? That means that we're going to start at, on each subinterval, there'll be 6 of them, 1, 2, 3, 4, 5, and 6. Those will all be the bases of a rectangle. Then we're going to start at the right endpoint of each rectangle. For example, the right endpoint of the first rectangle would be 1/2. We're going to go up to the curve there, and then over and create our first rectangle. Now, what will the area of that be? The area of that will be a base of 1/2 times whatever f of 1/2 is. So we're going to the height of the curve when x is equal to 1/2. So this would be f of 1/2 right there. If we went to the curve over here, that would be f of 0, but we're using the right endpoint for the height of the first rectangle. The second rectangle would start at the right endpoint, which is 1, and then go over and make that rectangle. And its area would be a base of 1/2, and its height would be f of 1. The next one, we would start at 3/2, we'd go over. So this one would be f of 1. This height would be f of 3/2 here. That's the height of the third rectangle times 1/2. So f of 3/2. then 2. And we have f of 2, 1/2 of f of 2. And then for the next one, we go up from 5/2. And so we have plus 1/2, which is the base, times f of 5/2. And finally, for the last one, we start at x equals 3. We go up to the height of the curve at 3, and we have 1/2 is the base, f of 3 is the height. All right, so we need to find those values of the curve there, and I'll make a small table in green. Down here, we have x, and we have f of x. And then finally, we're going to have 1/2 times f of x. So the x values that we're working with are, I'll just go ahead and put in the 1/2. That's the height of the first rectangle, then 1, then 3/2, then 2, then 5/2, and 3, using the right endpoints. Now, all we need to do is plug those values of x into our function. F of x is equal to 3x plus 2. So we plug in 1/2, that's 3/2 plus 2 is going to give me 7/2. Plugging in 2/2 is going to give me 9/2. No, plugging in 2 is going to give me 10/2. 3 times 1, is 3 plus 2 is 5. And in terms of halves, yes, that would be 10/2 or 5. The next one, 3/2, is going to give me 9/2 plus 4/2 is 13/2. And hopefully you can see that it's just going up by 3/2 each time. Next one would be 16/2, next one 19/2, and the next one 22/2. So you can see the pattern there. Now those are the heights of each rectangle. We want to multiply by the base, which is times 1/2, and that's going to give us 7/4, 10/4, 13/4, 16/4, 19/4, 22/4. And when we add those all up together, we are going to get a total of 87/4. And we can see that's higher than our estimate of our actual value of 78/4. And that is as it should be, because you can see each of the rectangles that we used go beyond the curve, and so that's going to over approximate. Now we want to do the same thing using the left endpoints. So for the left endpoints, I'll use a purple color here. For each, we're still going to have the same 6 bases of those rectangles, but instead of using the right endpoint, we're going to come over here and use the left endpoint as the height of each rectangle. And so the second one will look like that. The third one will start from there. The fourth one will go from here. The fifth one will go from here. Sixth one will go from there. All right, and you can see that in this case, the purple rectangles, they will under approximate. Well, let's take a look at what each purple rectangle is. Well, they all still have an area, a base of 1/2. But for the first one, it'll have a height which is f of 0. The second one, its left endpoint would be f of 1/2. So it'll have an area of 1/2 times f of 1/2. The third will be 1/2 times f of 1. And you can see that we're using exactly the same values that we used, except for the first one. The next one would be 1/2 times f of 3/2. and then plus 1/2 f of 2, then plus 1/2 f of 5/2. Now, we don't use, when we use the left endpoints, we never use the last one. When we use right endpoints, we never use the first value. So since we've already calculated these, I'll just go quickly and make a new table. We have x, f of x, and 1/2 f of x. This time instead starting at 0, at 1/2, at 1, at 3/2, at 2, and 5/2. So I'm going to get all the values from the other table: 7/2, 10/2, 13/2, 16/2, and 19/2. The first one would be 4/2, or 2. 3 times 0 is 0, plus 2 is 2, and that's 4/2. When I multiply each of those by 1/2, I'm going to get 4/4, 7/4, 10/4, 13/4, 16/4, and 19/4. Now, when I add those all up, I end up with 69/4. And you can see that my actual was basically right in between the 69/4 and the 87/4. And so that's all we need to do for this type of problem. We found the left-hand rectangular approximation. We found that second. First, we found the right-hand rectangular approximation, and I showed how that worked. Now, you could use your calculator to find all these values if it was more complicated, but that's an example of how this works.